Hi, welcome to this lesson on calculus. What is the derivative? Let's have a look at deriving from first principles, question 1. So let's recall the derivative formula. F prime x is defined as the limit as h tends to 0 of the average gradient, f of x plus h minus f of x all over h. So what I like to do on the side is what I like to call my algebraic gymnastics. So what is that? Well, so gymnastics. Okay, so my algebraic gymnastics is I like to evaluate what the entire expression of the average gradients will look like and then just plug it in to avoid lengthy calculations here on the side. So, f of x is defined as 3x plus 5. So what is f of x plus h? Well, wherever there's an x now, I'm going to replace it with x plus h. So it's going to be 3 times x plus h plus 5. And if I expand that out, it's going to be 3x plus 3h plus 5. So now if I do f of x plus h minus f of x, that's going to be 3x plus 3h plus 5 minus 3x plus 5. So that simplifies to 3x plus 3h plus 5 minus 3x minus 5. So 3x cancels with that negative 3x. 5 cancels with negative 5, and I'm just left with 3h. Okay, so therefore, on my left now, what am I left with? So it's equal to the limit. So you keep writing the limits until you actually evaluate the limit. So that's really important notation-wise. Okay, so we must make sure that our algebraic fluency is still in check whenever we write things in notation-wise, because we want to make sure we're writing it out logically and correctly, that it makes sense to us. So we know that this expression we just worked out is equal to 3h over h. So now 3h divided by h, the h's will cancel, and you're left with the limit as h approaches 0 of 3. So now we can apply the limits. Well, the limit of a constant is just that constant. It's 3. And we can visualize that. So if you draw the function y equals 3, that's just this horizontal line here, y equals 3. So as you approach 0 from both the left and the right, you're still approaching the y value of 3. Okay, so you can see you only apply the limits at the very end, and then you drop the limit as h tends to 0. And the whole goal of when you're doing first principles is to try to get those h's to cancel, because this h in the denominator causes a problem if you just substitute it in directly, right? You'll get division by 0, which is not allowed. So therefore, that's why when we do the algebraic expressions and simplification, the justification that we're looking for are that the h terms eventually cancel each other out. And we're just left with all terms where the h in the denominator is now gone. All right, so what does this mean? It means that if f of x equals 3x plus 5, then the derivative, first derivative, is just 3. Now, let's see what that means. Well, 3x plus 5, we know is a straight line graph. And this is of the form 3x plus 5. Now, the gradient, m, is 3. And can you see the gradient is also the derivative? And that makes sense because we said the derivative is the rate of change of your function. And the rate of change of a linear graph is the gradient. Okay, so it's nice when these concepts all link together. Awesome. I'll see you in the next one.